Hello everyone. I'm sharing my screen right now. Okay. Can somebody please confirm if my screen is visible? And can you also see when I am changing my slides? Yes. Can somebody please confirm if it is visible and it is changing when I'm changing the slides as well? Okay, I'm waiting. Is it changing? Please, can somebody please confirm if you can see my screen and the slides are changing as well? I've allowed your microphones. You can just unmute yourself and speak, or you can also respond in the chat section as well.
Yes, good evening, sir. The screen is visible, sir.
Okay, thank you, thank you.
Yeah.
And
Yes,
is
sir.
it changing as well?
Sir,
Uh,
sir,
Yes.
yes, visible, sir.
Okay. Okay, thank you. All right. Let's wait for a few more minutes for others to join and then we'll start the session. Meanwhile, if you have any doubts, then you can just ask your doubts right now and we can clear them up. If you have any doubts regarding week 1, week 2, or week 3 lectures, then we can take it up. We can discuss while we are waiting for others to join in before we can start the session. Yes, anyone has any doubts? All right, let's start the session. Hello, everyone. Welcome to the weekly discussion and doubt clearing session number 3 of the NPTEL course on concrete technology, NOC24-CE46, which is taken by Professor V. Bhattacharjee of IIT Delhi. I am Ashirvad Satpathy. I am a PMRF research scholar at IIT Delhi, and what I do is I take these weekly sessions of 2 hours where we discuss the different problems of the previous week's lectures, which we have already submitted the answers to, and the deadline has already passed. And then we also take some of the doubts that you might be having regarding the previous week's lectures. I'm also the officially assigned teaching assistant for this NPTEL course. There is another teaching assistant to this course. His name is Devojyoti. He usually takes his weekly sessions on Saturdays from 6 to 8 p.m. and I take my weekly sessions on Mondays from 6 to 8 p.m. All right. I would also like to mention that we have uploaded the previous week's lecture sessions, like the sessions that we take, these weekly discussion sessions. We uploaded the videos of those previous week's discussion sessions online on YouTube, and I have also pasted the link in the chat section of this meeting. I've also uploaded the lecture slides that we use during these meetings into an OneDrive folder, and you have also been provided with access to that link in the chat section. You can check it out whenever you want. Okay. In today's session, we'll be discussing the assignment 1 and assignment 2 questions of the week 1 and week 2 lectures. And at the end of this lecture, we will also be taking any doubts that you might be having regarding the week 3 lectures. So the first week's lecture was an introduction to concrete technology, how cement hydrates, and what influences the hydration of cement, and all of that stuff. And then in the second week's lectures, we saw what are the production processes regarding the cement, what are the different constituents that are present in cement, and what are the different types of cement and their applications, and how we can make those different types of cement by varying the proportions of the different constituents of cement, that is the Bogues compounds. So this is the brief summary of the week 1 and week 2 lectures, and the assignment 1 and assignment 2 questions are related to these lectures. And at the end, as I mentioned, we'll be taking the doubts of the week 3 lectures as well. So the first question of this assignment 1 was, which of the following properties is the weakness of cement? Low life cycle cost, moldability, brittleness, robustness. Which of these following properties is the weakness of cement? Yes? Can somebody answer to this question? Low life cycle cost, moldability, brittleness, or robustness? Yes, anyone would like to answer to this question? Which of this is the weakness of cement? Can somebody please try to answer to this question? Alright, the correct answer to this question is brittleness. So brittleness is the weakness of cement. It is not the low life cycle cost. In fact, cement or concrete is a low cost material, as we know. It is moldable. Cement or concrete in its fresh state can be molded into any shape or any formwork when poured on it. So yeah, in fresh state, in a plastic state, cement or concrete can be molded. So it has a good moldability. It has a low life cycle cost as well. And then what is robustness? So robustness of any material is its ability to resist a great change or great deviation in its desirable properties or desirable performance parameters when the input parameters or the surrounding conditions are changed a little. So a robust material is essentially a material which won't undergo a large deviation in its performance parameters when the input or the exposure parameters are changed within a certain range. So that is a robust material. So concrete is a robust material. Cement or concrete, they are robust material in the way that when you it is the performance of concrete or cement can be predicted uh, up to a certain degree without knowing so cement and or concrete is a robust material and it behaves predictably. So it has a great degree of predictability and it behaves in a predictable manner. But as we know, cement is weak in tension and brittleness is the sudden failure or fracture of cement or concrete. So this brittleness is induced when cement or concrete structures um, are applied with a tensile force or a tensile load. As they are weak in tension, so they don't undergo a large plastic deformation before failure or fracture, and therefore they fail in a brittle manner. So brittleness is one of the weaknesses of cement or concrete structures. But of course, cement or concrete can undergo a plastic deformation in its fresh state. It can flow like a flowy material. But when we're considering the hardened state, it doesn't go a large deformation and breaks in a brittle manner. How much the second moving on to the second question, how much carbon dioxide is produced during the production of 1 ton of ordinary Portland cement? 0.25 tons, 0.5 tons, 0.75 tons, 1 ton. Which of these options are correct? How much carbon dioxide is produced during the production of 1 ton of ordinary Portland cement? Can somebody answer to this question? All right. The correct answer to this question is it is 1 ton. So 1 ton of carbon dioxide is produced during the production of 1 ton of ordinary Portland cement. It is a straightforward question. So we have also discussed this in the previous sessions as well. Around 50 to 60% of this carbon dioxide comes from the clinkerization reaction or the calcination of the limestone. When limestone gets converted to lime and carbon dioxide, so that carbon dioxide released is almost constitutes for the 50 to 60% of the total carbon dioxide emission associated with cement production. And the rest is due to indirect emissions, which could be due to burning of fuel or due to transportation, due to grinding by using of ball mills, due to the use of electricity in all of the processes associated with the production, and so on. So that is the breakup of the total carbon dioxide emission associated with 1 ton of ordinary Portland cement. Right? Moving on to the third question, what is the formula of ettringite? And 4 options have been given. It is C3AH6, C6A S bar 3H6, C6A S bar 3H32, C4A S bar H12. Which of these 4 options are correct? What is the formula of ettringite? It's a very straightforward question. Can somebody answer to this question? Yes? Alright, the correct answer to this question is C6A S bar 3H32. It is important to remember that ettringite is also called AFT phase, and by AFT it means that it is the abbreviation for aluminate, ferrite, tri. So the T in AFT means tri. In this case, it is trisulfoaluminate. So this tri is can be associated with the sulfate that is available. So that rules out the first and the fourth option. And then we also know that ettringite contains a large amount of water. It contains 32 molecules of water. So the third option is correct answer. So how is ettringite formed? When C3 or aluminate phases react with gypsum and water, that gives rise to the AFT phases or ettringite, and that is how we know how ettringite is formed. Moving on to the fourth question, what is the purpose of adding gypsum into the cement? The options given are, it reduces the setting time of cement, it prevents flash set, it reduces the heat of hydration, or it increases strength. Which of these options are correct regarding adding gypsum to the cement? Can somebody answer to this question? Why do we add gypsum to cement? Does it reduce the setting time of cement? Does it prevent flash set? Does it reduce the heat of hydration? Or does it increase strength of the cement or concrete? Which of these options are correct? Can somebody answer this question? Yes?
Yes, sir. Prevent flash set.
It prevents flash set, right? Thank you. So yeah, that's the correct answer. The purpose
फ्लैश
of
सेट का
adding gypsum into cement is
फ्लैश सेट का
it
मतलब
prevents
सर
the
जैसे
flash setting.
जैसे उसमें मतलब कि सीमेंट में पानी मिलाते हैं ना तो वो हाइड्रेशन प्रोसेस स्टार्ट हो जाता है। हाँ तो मतलब कि वो
Right.
हाइड्रेशन प्रोसेस स्टार्ट होने के बाद में जो बोझ कंपाउंड बनता है तो वो हार्ड करने लगता है। सीमेंट को बहुत जल्दी हार्ड करने लगता है, तो उसी को रोकने के लिए जिप्सम मिलाया जाता है।
Okay. बोग्स कंपाउंड बनता है हाइड्रेशन होने से? ऐसा होता है क्या?
सबसे पहले तो सर C3A शायद बनता है। हम्म,
जी, thank you. So the idea is C3. How does flash set occur? So when there is excess of aluminates or C3A present in the cement, C3A being one of the Bogues compounds, and it has a high heat of hydration. So these C3A molecules, they dissolve in the pore solution and react very fast with the water to produce what we call as the hydrogarnets. This happens when there is no gypsum. So these crystalline hydrogarnets are formed when C3A reacts with water in the absence of gypsum. And these hydrogarnets, as they are crystalline in structure and they have a large volume, they set the cement or concrete very quickly, and that leads to the flash set. It reduces the workable time, it reduces the open time that we have with respect to the cement or concrete. So adding gypsum, what does it do? It forms a layer around these aluminates and prevents them from reacting too fast, and also takes part in the reaction between the aluminates and water. So aluminates, instead of directly reacting with the water, they react with gypsum and water in order to produce ettringite. Now ettringite has a lower volume than that of hydrogarnets, and it takes time for all the aluminates to react with gypsum and water, and therefore it increases the adding gypsum increases the open time of this cement and concrete and prevents the cement and concrete from flash setting. So yeah, flash set is caused by the reaction of aluminates or C3A with water in order to produce hydrogarnets. But in the presence of gypsum, these gypsum molecules hinder the reaction between aluminates and water directly and increase the workable time or the open time of the cement and concrete mixture. Now I won't rule out the last two options as to it reduces the heat of hydration or it increases the strength. These are not completely wrong, because when we add gypsum, the heat of hydration or the heat peaks that we obtain could be slightly lowered depending on the total amount. I mean, what is the amount of gypsum we are adding? If we have excess gypsum, then it will retard the system completely and the heat of hydration will also reduce. And again, when there is no gypsum and hydrogarnets are getting formed, when we add gypsum to the structure, since ettringite is formed not instantaneously, rather it forms throughout a duration, so that increases the strength. So sometimes adding gypsum increases the strength as well, because ettringite is a denser material than that of hydrogarnets, and that leads to taking up lower amount of volume, and with the continued formation of ettringite throughout the duration of or the life the duration of life of the structure or the cement or concrete, it increases the strength. So these last two statements are not completely wrong. Gypsum could increase the strength a little bit, and it also could reduce the heat of hydration by a factor. But yeah, the first option, it is wrong. It doesn't reduce the setting time of cement. Rather, it sometimes increases the setting time or the open time or the workable time that we have with the cement and concrete. Right? Alright, moving on to the fifth question. Which of the following compound has the minimum heat of hydration? The options given are tricalcium silicate, dicalcium silicate, tricalcium aluminate, tetracalcium aluminoferrite. So tricalcium silicate is also known as C3S or A-lite. Dicalcium silicate is also known as C2S or B-lite. Tricalcium aluminate is known as C3A or aluminate. And tetracalcium aluminoferrite is also called as C4AF. That is aluminoferrite, C4AF, or just ferrite. Which of these compounds has the minimum heat of hydration? Can somebody answer to this question? Yes, can somebody try answering this question? This is a very straightforward question.
The dicalcium silicate.
Dicalcium silicate or baelite, thank you. Yes, that's the correct answer. Dicalcium silicate has the lowest or the minimum heat of hydration among all these four Bohm's compounds. We know that if we arrange them in an order, we know that tricalcium silicate has the highest heat of hydration. Tetracalcium aluminoferrite is around the same amount of heat. Then tricalcium silicate has the comes in the after that. So it has the second highest heat of hydration, and the minimum heat of hydration comes with
सर
dicalcium silicate.
सर ये हीट ऑफ हाइड्रेशन मतलब
Yes.
कि किन बातों पर डिपेंड करता है? जैसे इसमें तो सिर्फ हमने रिजल्ट पढ़ लिया कि इसमें ज्यादा होता है, इसमें कम होता है, लेकिन क्यों ज्यादा होता है ये तो पता नहीं है.
ओके, क्यों ज्यादा होता है ये इसका रीजन आपको पता लगेगा आइसोथर्मल कैलोरीमेट्री कर्व से. आपने ये शायद लेक्चर में भी आपको पढ़ाया गया होगा. सो क्यों ज्यादा होता है किसी का हीट ऑफ हाइड्रेशन डिपेंड्स ऑन 2 to 3 फैक्टर्स. क्या है वो फैक्टर्स? जैसे कि उनकी डिसोल्यूशन और उनकी डिसोल्यूशन रेट, उनकी फाइननेस, एंड वो क्या प्रोडक्ट बनाते हैं आफ्टर रिएक्टिंग विद द पोर सोल्यूशन. सो जैसे ट्राइकैल्शियम सिलिकेट और C3S reacts with water to form CSH plus CH. Similarly, dicalcium silicate also reacts with water to produce CSH and CH. Aluminates react with water and gypsum to produce ettringite, सो इट ऑल्सो, ये डिपेंड ऑल्सो करता है, इस पे भी करता है कि जो प्रोडक्ट बन रहे हैं उनकी क्या मॉलिक्यूलर मास है, जितनी उनकी एनर्जी होगी या जितनी उनकी मास होगी, जो जो इतना हैवी प्रोडक्ट बनेगा उस रेशियो से भी उतनी ही हीट रिलीज भी होगी. तो it also depends on these reaction kinetics as well. So इसलिए ट्राइकैल्शियम एल्यूमिनेट में ज्यादा हीट भी प्रोड्यूस होता है as compared to dicalcium and tricalcium silicate. So reactant and the reaction products, इन पे डिपेंड करता है कि कितनी हीट रिलीज होगी. आप ये भी देख सकते हो कि C3S and C2S के रिएक्शन प्रोडक्ट सेम है, बट C3S में ज्यादा हीट रिलीज इसलिए होती है क्योंकि C3S has a higher molecular mass, so it is going to react faster. जो फास्टर रिएक्ट करेगा, जो ज्यादा जल्दी डिसॉल्व होगा, जो ज्यादा फास्ट रिएक्ट करेगा वाटर और अदर कंपाउंड्स के साथ, उसकी हीट रिलीज ज्यादा होगी.
सर लेकिन मतलब कि इसमें तो सिर्फ ऑब्जर्वेशन से, मतलब कि जैसे ये कोई ने मतलब इनको मेजर किया होगा.
हाँ, मेजर करते हैं, मेजर आप कर सकते हो, जैसे मैंने बताया कि आप कैलोरीमीटर से मेजर कर सकते हो इसको. सो हीट को मेजर करने के लिए भी, हीट ऑफ हाइड्रेशन को मेजर करने के लिए वी यूज कैलोरीमीटर. कैलोरीमीटर क्या करता है? एसेंशियली इट्स एन इक्विपमेंट जिसमें कि एक सिंक होगा
हीट इवॉल्व
और उसमें हीट इवॉल्व होगा, राइट. सो वी नो दैट दीज रिएक्शंस, इसमें इस सारी रिएक्शंस आर एक्सोथर्मिक इन नेचर, मीनिंग दैट दे emit energy or they release energy when these reactions take place.
मतलब
अगर release, right, so जब रिलीज होगी एनर्जी उसमें से, तो उसका हीट रिलीज होगा, वो हीट को कैप्चर करता है. एंड इसको हम मेजर कर सकते हैं यूजिंग आइसोथर्मल कैलोरीमीटर. आइसोथर्मल का मतलब ये है कि टेम्परेचर कांस्टेंट है. तो अगर हम टेम्परेचर को कांस्टेंट करना चाहते हैं एंड एक हीट रिलीज हो रहा है, इसका मतलब क्या है? एक कहीं पर हीट रिलीज हुआ, हमको टेम्परेचर कांस्टेंट मेंटेन करना है, मतलब वो टेम्परेचर को रिड्यूस कर देगा ताकि वो टेम्परेचर को मेंटेन कर सके, तो वो हीट को खींच लेगा. सिमिलरली अगर हीट ले रहा है कोई सिस्टम, तो वो हीट को उतना प्रोड्यूस करेगा एंड उस इन ऑर्डर टू मेंटेन दैट टेम्परेचर. तो कितना हीट रिलीज हो रहा है, कितना हीट उसको कैप्चर कर रहा है, या कितना हीट वो उसको देना पड़ रहा है, बेस्ड ऑन दैट दिस सिस्टम कैलकुलेट्स द हीट रिलीज और हीट ऑफ हाइड्रेशन, द आइसोथर्मल कैलोरीमीटर सिस्टम. ठीक है. It has also been taught to you in the lectures as well. So a typical isothermal calorimeter plot of an ordinary Portland cement looks somewhat like this. तो ये ऐसा होता है, and it can be characterized into different phases. So the x-axis here is the time duration or the age, and the y-axis is the heat evolved and the initial heat burst. So this is heat evolved and this is time duration or the age. The initial heat evolved, that is due to the dissolution. So dissolution reaction is also exothermic in nature. So the first stage, and there is a high heat burst, that is due to the dissolution. उसके बाद एक induction period होता है. In this induction period, the second phase, the heat is not completely zero, but there is some heat over there. Now, after the induction period, it starts accelerating. And at the onset of this acceleration phase, at somewhat around here, it corresponds with the initial set of the cement. Okay? And finally, it accelerates, and the first peak is the aluminate, so the silicate peak. Okay? So उसके बाद ये वो heat release होता जाएगा, and initial set के बाद finally somewhat around here, this is the alite peak, alite hydration peak. अब alite hydration peak के बाद there will be alite gypsum जाके alite में absorb हो जाएगा, there will be gypsum depletion in the system, and finally this gypsum will be dissolving from the alite sorry the CSH, ये जाके जो gypsum जाके CSH में absorb हुआ होगा वो जाके dissolve हो जाएगा, and then there will be an aluminate hydration peak. So this second peak corresponds with the aluminate hydration peak, and finally it decelerates, and there will be a very small hump at a later stage, somewhat around 14 to 15 hours, and this corresponds with the AFM peak. In normal OPC systems, this AFM peak is the monosulfo-aluminate peak. So पहले ettringite का peak आता है, उसके बाद monosulfo-aluminate का peak आता है. When the gypsum is completely depleted from the system, now ettringite formation is not favored much. So now the monosulfo-aluminate, which has only one molecule of sulfate in it, that is getting formed instead of trisulfo-aluminate, which is ettringite, right? So this is how you can, this is the typical representation of the isothermal calorimeter plot, and this is how you can measure the different heat amount evolved when all of these compounds that are present in the cement react with water. Alright? So इससे आपको पता लग सकता है कि कौन सा constituent of the cement कितना heat release करता है, and किस point और किस age पे कौन सा maximum reaction undergo करता है. So that's how it is.
जी सर, थैंक यू.
Okay, moving on to the week 2 assignment 2 questions. The first question was, what is the cement to sand ratio for testing of mortar cubes for strength? Is it 1:1, 1:2, 1:3,
1:3.
1:4? 1:3 is the correct answer. Thank you. So the correct answer is 1:3. We take one portion of cement
सर
and
ये
three
सब
portion of
मतलब
standard
एक्सपेरिमेंट
sand.
से निकाला गया है ना सर कि 1:3 ही होगा ऑब्जर्वेशन से. इसको
हाँ, एक तरीके से एक्सपेरिमेंट से निकाला गया. ये एक्चुअली स्टैंडर्ड फॉर्मूले हैं. तो these are empirical parameters that have been set up by the Bureau of Indian Standards, and हाँ, ये बहुत सारे टेस्ट करके इनकी BIS की कमिटी इन रिजल्ट्स को एनालाइज करके इस चीज पे अराइव करती है कि कितना किसका प्रोपोर्शन लेना है. एंड दिस इज ऑल्सो वन वे टू स्टैंडर्डाइज द टेस्टिंग ऑफ स्ट्रेंथ ऑफ सीमेंट. सो बेसिकली इसमें करते ये हैं कि ईच क्यूब, मोटार क्यूब ऑफ सीमेंट बनाने के लिए आप, और मोटार बनाने के लिए मतलब फॉर गिवन सीमेंट आपको अगर सीमेंट की स्ट्रेंथ जाननी है तो आपको मोटार क्यूब्स बनाना पड़ेगा. एंड फॉर ईच ऑफ दिस मोटार क्यूब्स यू हैव टू टेक 200 grams of cement and 600 grams of standardized sand. Now the standardized sand has to be taken in equal amounts from 3 grades: grade 1, grade 2, grade 3. इसके 3 grades हैं based on the sizes of the standard sand, and these standard sand has to be procured. It has been mentioned in the Indian standards that this standard sand has to belong to one of the regions of Tamil Nadu. It is probably, I don't remember, I don't remember exactly, but it is somewhat around Ennore or something. It is called Ennore sand, I guess. I'm not sure exactly, but yeah. So this standard sand has to be procured from that region of Tamil Nadu of India, and it has to be taken in equal amounts from grade 1, grade 2 and grade 3 plus water, and this water can be calculated from the normal consistency test. When we mix all of these constituents, we'll be able to produce only one mortar cube. So depending on the number of mortar cubes you want to produce, you can't just make a big mix and prepare the mortar cubes. No, you have to take these proportions and prepare each of the mortar cubes separately 200 grams and 600 grams of sand, 200 grams of cement, and water from the normal consistency per cube. So these are different ways that the Indian standards have mentioned so as to have a consistency in the results of the strength test of cement. So be it you're testing it in any part of India or
सर तो
apart from the little variations in the surrounding conditions or the environmental conditions, if you follow these methods, you'll be able to
तो
get
अगर जो कभी
consistent
भी हमको
results for
चेक
your
करना
cement
होगा
strength.
क्यू का स्ट्रेंथ, तो ये सैंड जो है उसी प्रॉपर्टी का रहेगा तब ना, मतलब कि वो सैंड तो वहीं से लाना
Exactly,
पड़ेगा जहाँ
yes.
वो सैंड मिलता है, और जो मेरा लोकली अवेलेबल नहीं है तो फिर
बिल्कुल
तो दिक्कत हो जाएगा।
नहीं, आपको अगर सीमेंट की स्ट्रेंथ टेस्ट करनी है, आपको लोकल सैंड यूज नहीं कर सकते हो, आपको स्टैंडर्डाइज्ड सैंड ही पता करना है। सीमेंट स्ट्रेंथ जो कि 33 ग्रेड और 43 ग्रेड और 53 ग्रेड की आती है, जैसे स्ट्रेंथ ओपीसी की बेस्ड ऑन IS 269, उसका मतलब क्या होता है? 33 मेगापास्कल्स, 43 मेगा, अभी तो 33 नहीं आती, 43 मेगापास्कल्स, 53
जी
मेगापास्कल्स एट 28 डेज। अगर आपको ये सीमेंट की स्ट्रेंथ टेस्ट करनी है कि ये क्राइटेरिया पास हो रहा है कि नहीं एज पर IS 269, देन यू हैव टू यूज स्टैंडर्ड सैंड ओनली। इसकी IS 269 में ये सारे क्राइटेरिया हैं। 3 डे में कितना स्ट्रेंथ होना चाहिए, 7 डे में कितना स्ट्रेंथ होना चाहिए, 28 डेज में कितना स्ट्रेंथ होना चाहिए। सो इस सारे क्राइटेरिया अगर पास करेगा, आपने यही मटेरियल्स यूज किया, स्टैंडर्ड सैंड एंड द वाटर फ्रॉम द नॉर्मल कंसिस्टेंसी, ये सारे पैरामीटर यूज करके अगर आपका ये सारा 3 डे, 7 डे एंड 20 डे स्ट्रेंथ एज मेंशन्ड इन IS 269 तभी पास कर रहा है, तब जाके ये माना जाएगा कि ये सीमेंट इतने ग्रेड का है। एंड द स्टैंडर्ड सैंड हैज टू कम फ्रॉम द एनोर रीजन ऑफ तमिलनाडु। सो आपको सीमेंट की स्ट्रेंथ जानने के लिए आपको स्टैंडर्ड सैंड ही यूज करना पड़ेगा। यू कांट यूज अ लोकली अवेलेबल सैंड और रिवर सैंड और क्रशर सैंड। एंड नॉर्मल कंसिस्टेंसी आपको विकास apparatus से निकालना पड़ेगा। बेस्ड ऑन दैट आपको वाटर का प्रोपोर्शन निकालना पड़ेगा। दैट इज आल्सो गिवन इन द कोड प्रोविजन, कोडल प्रोविजंस। जो मोटार क्यूब की साइज होती है वो 70.6 mm है। क्यूब साइज की मोल्ड होती है। So these are all the standard parameters that have been set up by the Indian standards in order to obtain
Yes.
consistent results of the cement strength. ठीक है?
लेकिन सर अगर जो दूसरे पार्ट में हमको बनाना है, मतलब कि कोई भी कंस्ट्रक्शन का काम करना है, वहां पर इस तरह का सैंड अवेलेबल नहीं है, तो वहां पर तो जो जिस सीमेंट का हम इस्तेमाल करेंगे उस सीमेंट तो पास करेगा ही नहीं, तो ये जो टेस्ट है।
नहीं, आपको सीमेंट पास कर रहा है कि नहीं कर रहा है, अगर आपको चेक करना है, देन आपको ये स्टैंडर्ड सैंड प्रोक्योर करना पड़ेगा। आप कोई भी रीजन ऑफ द कंट्री में काम कर रहे हो, आपको सीमेंट की स्ट्रेंथ चेक करनी है, तो आपको स्टैंडर्ड सैंड से ही मोटार क्यूब बना के उसकी स्ट्रेंथ देखनी है। आप लोकली अवेलेबल सैंड यूज नहीं
तो
कर
सर
सकते।
पूरा
अगर वो
पूरा सैंड
लोकली अवेलेबल सैंड से
पूरा कंस्ट्रक्शन करना पड़ेगा सर, तो फिर पूरा सैंड तो दूसरी जगह से नहीं ना ला सकते हैं।
नहीं, कंस्ट्रक्शन नहीं, कंस्ट्रक्शन के लिए अगर आपको कंक्रीट बनाना है, वो तो आपको मिक्सचर डिजाइन से बना दो, मिक्स डिजाइन बना के बना दो। उसके
जी
लिए आपके पास जो भी लोकली अवेलेबल मटेरियल है वो आप यूज कर सकते हैं, ठीक है। बट वो तो कंक्रीट की स्ट्रेंथ आएगी उससे। जो भी आप मटेरियल यूज करोगे उसके बेसिस पे कंक्रीट की स्ट्रेंथ आएगी, वो आप कर सकते हो। बट अगर आपको सीमेंट की स्ट्रेंथ उसमें, अगर कंक्रीट की स्ट्रेंथ जानने के लिए सीमेंट की भी तो कौन से ग्रेड की सीमेंट ले रही हो, उसकी भी तो स्ट्रेंथ डालनी होगी। अब वो सीमेंट की स्ट्रेंथ आपको अगर पता करना है, तो आपको मोटार क्यूब्स कास्ट करने होंगे यूजिंग द स्टैंडर्ड सैंड। अगर यू हैव टू चेक, लेट्स से इन अ गिवन प्रोजेक्ट आपको बहुत सारा सीमेंट प्रोक्योर करना है, लेट्स से 100 टन्स और 1000 टन्स ऑफ सीमेंट आपको प्रोक्योर करना है। अब आप इतनी बड़ी प्रोजेक्ट के लिए इतना बस सीमेंट का जो स्ट्रेंथ है वो तो चेक करोगे ना, क्या पता उसने इंडस्ट्री ने मिला के दिया हो, कुछ कम स्ट्रेंथ की मटेरियल दे दी हो आपको। तो उसके लिए आपको स्टैंडर्ड सैंड लाना है और रैंडमली बेस्ड ऑन द सैम्पलिंग मेथड्स एज मेंशन्ड इन द ब्यूरो ऑफ इंडियन स्टैंडर्ड्स, सैंपल करके उस सीमेंट को निकाल के और स्टैंडर्ड सैंड को निकाल के मोटर क्यूब्स कास्ट करनी है, और आपको चेक करना है सीमेंट की स्ट्रेंथ पास हो रही है नहीं, जो मेंशन किया है आपके वेंडर ने। जब आपको सीमेंट दिया है, जो मेंशन किया है कि इतनी ग्रेड की सीमेंट है,
जी
इतना
सर,
स्ट्रेंथ आना
समझ
चाहिए, वो स्ट्रेंथ आ रहा है कि नहीं आपको चेक करना है।
हमको
आप कंक्रीट के लिए कोई भी लोकली अवेलेबल मटेरियल यूज कर सकते हो, बट सीमेंट टेस्ट करने के लिए आपको एक स्टैंडर्डाइज्ड मेथड से ही टेस्ट करना होगा सीमेंट का ग्रेड, एंड दैट इज यूजिंग स्टैंडर्डाइज्ड सैंड। ठीक है,
जी सर समझ गए। हमको लगा कि पूरे प्रोसेस बनाना पड़ेगा।
नहीं नहीं, पूरे आप प्रोजेक्ट में आप कंक्रीट के लिए कोई भी लोकली अवेलेबल मटेरियल यूज कर सकते हैं, बट सीमेंट का स्ट्रेंथ देखने के लिए आपको ये स्टैंडर्ड पैरामीटर्स फॉलो करने होंगे जो इंडियन स्टैंडर्ड्स में मेंशन किया गया है, सो दैट आपको हर जगह पे, आप कोई भी पार्ट ऑफ इंडिया में करो, आपको सीमेंट की स्ट्रेंथ आपके मटेरियल से अफेक्ट नहीं होगी, यू विल गेट कंसिस्टेंट रिजल्ट्स फ्रॉम देयर।
जी सर, थैंक यू।
Okay, all right, moving on to the second question of this assignment 2. The question was, which of the following is the characteristic of sulfate resisting cement? Low C3S or A light, low C2S or B light, low C3A content, low C4AF content. Which of these is the characteristic feature of sulfate resisting cement? And why do we need that? Can somebody answer to this question? Why do we want low quantity of one of these phases in the sulfate resisting cement? Yes? If you want to answer this question, then you can just raise your hands or unmute yourself and speak.
सर C3A।
Yes, C3A. Right. That's the correct answer. Low C3A content is
लो
required in sulfate
एल्यूमिनियम
resisting
से
cement. Can you answer why?
Sir, can you hear me? Okay.
Yes, Divya,
If
I can
there's
hear you.
excess of C3A, that will react with the sulfate and it will form ettringite, which can cause cracks, which will be expansive, which can cause cracks.
Right.
Thank
Right. That's the correct answer. Thank you. Yeah. Yes, so the correct answer to this question is low C3A content is required in sulfate resisting cement. Now, typically where is surface resisting cement used? When cement is used to construct any structured elements which are in contact with soils or any other source of sulfates. So generally in soil, its soil is rich in sulfates, and when structural elements such as foundations, piers, or retaining walls are constructed over the soil, the sulfates from the soil get ingressed inside the concrete structures. Now, it is fine when we also add sulfate to the cement in the form of gypsum to control the setting of cement, right? So when sulfate is available in the cementitious system at a early stage, when the cement or the concrete is plastic in nature and the sulfate is available, then the C3 can react with the sulfate. The aluminates react with the sulfate and water in order to produce ettringite. Ettringite is good for us when it is the cement and concrete is in its early age, meaning that it is in a fresh or flowy state. And ettringite is a crystalline material. It occupies a larger volume than the solid itself, the aluminate itself, and therefore it occupies the voids that are present and provides us strength. But when the concrete is in a plastic state or in a fresh state, if ettringite is formed, then there is enough void volume to accommodate this ettringite formation, and therefore it will provide strength to us. Now, when sulfates are introduced to the concrete structure at a later stage, when the concrete has already hardened, then if there is high amount of aluminates in your system and some of the aluminates is still unreacted, it has not reacted, then this sulfate will come in contact with these the unreacted aluminates and react with water in order to produce ettringite at a later age. Now, this ettringite, again, it is, as we know, is a crystalline material. It will occupy a higher volume, but now the concrete has hardened and there is not enough plastic nature of the concrete in order to accommodate the expansion volume due to the formation of ettringite. Now, due to this expansive force that is caused by the formation of ettringite, there is the ettringite wants to expand inside the concrete, and that in turn applies a tensile force inside that, creates a tensile stress inside the concrete matrix. And as we know, concrete is weak in tension, therefore this expansion in volume will lead to cracking. So ettringite formation at an early stage is good for us. It increases the strength, it reduces the porosity, but when it is formed in a hardened state, then it leads to expansion in volume and further cracking in the concrete structure. So when we want to construct our structural elements which are prone to areas with high sulfate concentration or which are prone to sulfate attack, there we want the aluminate content in those cements to be low, so that whatever aluminates are present, they'll react at the early stage of hydration, so that there won't be any further aluminates in the hardened state to react with the sulfates, even if there is a sulfate attack at a later stage. All right. So this is the idea behind low aluminate content in sulfate resistant cement. Moving on to the third question. Expansive cement has a high amount of silica, alumina, ferrite, or lime. Expansive cement has a high amount of which of these phases? Silica, alumina, ferrite, or lime? Can somebody answer to this question?
Sir, alumina.
Alumina, right? That's the correct answer actually. So expansive cement has a high amount of alumina hydrates. Thank you. As you might have also seen this in the lecture as well. And I have taken this picture from the NPTEL lecture course, and you can see here that expansive cement has a high alumina content. It is generally made from by burning gypsum and bauxite and chalk. With these minerals are burnt together in order to produce expanding agent. Now, bauxite is the aluminum ore and that contributes to the high alumina content in this expansive cement. When we burn this, the carbon dioxide from the chalk is emitted out, and when bauxite and chalk and gypsum are burned together, they produce sulfo-aluminate phases. So the combination of gypsum, bauxite, and chalk produce sulfo-aluminate phases, and this sulfo-aluminate phases are expansive in nature. Now these expanding agents can be used with OPC and slag, and expansive cements can be produced. Now the purpose of using this expansive cement is majorly to fill the cracks, anywhere to fill the cracks, or to fill the crevices in tunnels, or anywhere else. So the major purpose of using this expansive cement is to fill cement in the areas which are not accessible directly to us for pouring the concrete or cement. So
सर
almost all of the expansive materials, be
अगर
it
जो इसको क्रैक में
epoxy
इस्तेमाल
or
करेंगे सर, तो
expansive
फिर
epoxy
तो वो
or
क्रैक में अगर जो ये
grout
सीमेंट
cement or
एक्सपेंड करने
expansive
लगेगा
cement,
तो क्रैक को तो
most
और
of these
बढ़ा देगा
materials,
ना।
the purpose major, yes. क्रैक विड्थ और बढ़ा देगा नहीं, जब क्रैक कहीं पे होता है तो आप उसको क्रैक को क्लोज करना चाहते हो। अब आप अगर एक्सपेंसिव सीमेंट डालोगे उसमें तो क्या करेगा, हाँ वो एक्सपैंड तो करेगा, एक्सपैंड करके क्या करेगा, क्रैक को फिल कर देगा। एंड इसको करने का मतलब ये है कि जब आपके क्रैक्स फॉर्म हो जाते हैं कंक्रीट स्ट्रक्चर में, those are pathways for water and other chemicals or ions to get inside your concrete and lead to corrosion of the steel reinforcement inside. अगर हम क्रैक्स को बंद कर देंगे यूजिंग एक्सपेंसिव सीमेंट तो उससे क्या होगा, water or any other chemical ions cannot get inside the concrete, and therefore your concrete will be protected from the outside ingress of these deleterious materials. तो ये इसका मेजर पर्पस होता है। तो क्रैक विड्थ नहीं बढ़ाएगा क्योंकि ये बहुत ज्यादा इन सीमेंट्स में बहुत ज्यादा स्ट्रेंथ नहीं होती है। ये बहुत एक्सपैंड तभी तक करते हैं जब तक इनको फ्री वॉल्यूम मिलता है। जब क्रैक्स को वो फिल कर देगा तब और ज्यादा एक्सपैंड नहीं कर पाएगा, और उसके बाद वो हम उसको ट्रॉवल ऑफ कर देंगे या फिर
तो अगर जो इसमें क्रैक भरेंगे तो ये तो सिर्फ फुल जाएगा और स्ट्रेंथ नहीं देगा, तो फिर से तो ये मतलब कि हट सकता है ना, कवर सकता है। यानी क्रैक का सर जहां पर एक बार लगाए इसको तो ये तो फिर से फिर से उखड़ जाएगा। अगर जो इसमें ये स्ट्रेंथ नहीं रहेगा इसमें तो ये मजबूत वाला नहीं रहेगा, तो ये तो फिर से कवर
एंड हाँ नहीं मजबूत वाला नहीं रहेगा, नहीं है। व्हाट आई एम ट्राइंग टू से इज एक्सपेंसिव सीमेंट का मेन पर्पस स्ट्रेंथ देना नहीं होता है। एक्सपेंसिव सीमेंट का मेन पर्पस होता है टू फिल दोज इनएक्सेसिबल एरियाज सो दैट वी हैव अ होमोजेनियस पोर ऑफ द कंक्रीट और सीमेंट, दैट्स इट। स्ट्रेंथ के लिए हम दूसरे सीमेंट्स यूज कर सकते हैं जिसमें अब स्ट्रेंथ चाहिए, क्योंकि एक्सपेंसिव सीमेंट इज नॉट वेरी चीप, इट्स आल्सो कॉस्टलियर। सो स्ट्रेंथ के लिए हम ये सीमेंट यूज नहीं करते, हम इसको यूज करते हैं क्रैक फिलिंग और ये सब चीजों के लिए। और आप जो कह रहे हैं कि क्रैक बार बार वहां पे रिपेयर आपको नीड करेगा क्योंकि वो ये स्ट्रेंथ इस सीमेंट में स्ट्रेंथ नहीं है तो टूटता जाएगा। रिपेयर की फ्रीक्वेंसी बढ़ती है not just because of the materials but because how we finish the surfaces, how you prepare the surfaces before applying the repair material. तो आपको रिपेयर मटेरियल को अप्लाई करने से पहले उन सर्फेसेस और सबस्ट्रेट कंक्रीट को अच्छे से पहले प्रिपेयर करना चाहिए, एंड देन ओनली यू शुड अप्लाई द रिपेयर मटेरियल। और रिपेयर मटेरियल भी चूज करना चाहिए बेस्ड ऑन द सबस्ट्रेट कंक्रीट। तो उसकी एक प्रॉपर स्ट्रैटेजी होती है रिपेयर करने के लिए। क्योंकि हम उसको अच्छी तरीके से करते नहीं है, ठीक तरीके से जो स्ट्रैटेजी है उसको फॉलो नहीं करते, इस वजह से हमारी रिपेयर मटेरियल खराब होती है और बार बार हमें रिपेयर करना पड़ता है। तो स्ट्रेंथ नहीं है इसलिए
नहीं, वो
रिपेयर
घर में क्या
मटेरियल
होता है
खराब हो
सर, घर
जाएगा,
में भी
ऐसा
कभी
कोई
कभी क्रैक पड़
डायरेक्ट
जाता है तो वहां पर
कोरिलेशन।
सीमेंट भरते तो फिर से बार बार वहीं पे क्रैक पड़ता है।
जी जी जी, बिल्कुल। वो ये इसीलिए होता है क्योंकि हम जो जब रिपेयर करते हैं ना, रिपेयर करने को हम डायरेक्टली क्या करते हैं, कहीं पे टूटा हुआ है उस पे सीमेंट लगा के चले जाते हैं। बट ऐसा नहीं होता है, उस पे डर्ट होती है, उस पे धूल मिट्टी होती है, उसको अच्छे से क्लीन करना पड़ता है, उस सरफेस को पहले प्रिपेयर करना पड़ता है, उसमें बॉन्डिंग एजेंट्स मिलानी होती है, फिर जाके हम रिपेयर मटेरियल ऐड करते हैं। एंड रिपेयर
सर
मटेरियल को भी
हम
पहले
जैसे आप बोल रहे
इस
कि
तरीके
रिपेयर
से
के लिए
टेस्ट किया
एक्सपेंसिव यूज
जाता
हो
है
रहे हैं, फिर
ताकि वो
इसका और
मैच करे
ग्राउट सीमेंट
हमारे
का फर्क क्या है?
सबस्ट्रेट कंक्रीट और सबस्ट्रेट मटेरियल को। ठीक है।
कि ग्राउट सीमेंट भी हम ऐसे क्रैक रिपेयर करने के लिए भी यूज करते हैं ना?
ग्राउट सीमेंट और इसका फर्क एज इन आप किस रेस्पेक्ट में पूछ रही
तो कहाँ
ग्राउंड
राइट राइट। तो ग्राउट सीमेंट और एक्सपेंसिव सीमेंट मेजरली सी एनी ऑफ दिस एक्सपेंसिव मटेरियल्स द मेजर any of these expensive materials, the major purpose of using these expensive materials is to fill the cracks or access or pour the concrete or cement in the inaccessible areas as I mentioned. तो ग्राउट सीमेंट भी उसको भी यूज करते हैं, एक्सपेंसिव सीमेंट को भी यूज करते हैं, बट ग्राउट सीमेंट हमें
ग्राउट में तो शायद
स्ट्रेंथ भी
शायद
देता
शायद
है।
सर उसमें स्ट्रेंथ भी
एक्सपेंसिव
रहता है
सीमेंट
ना, मतलब कि वो तो
ऑल्दो स्ट्रेंथ
स्ट्रेंथ के
देता
लिए
है,
शायद
बट
इस्तेमाल करते हैं
सी
ग्राउट
दीज आर
की।
ऑल वेरी सिमिलर
क्योंकि
सीमेंट
वो
टाइप्स, इट्स नॉट वेरी,
नहीं,
इट्स नॉट
कहीं
वेरी
पे
डिफरेंट
फाउंडेशन
फ्रॉम
में
दैट।
प्रॉब्लम आ गया
बट
तो वहाँ पर ग्राउटिंग कर
मेजर
देते हैं तो
पर्पस
वो
इनका
तो
यही होता
मजबूत कर देता है ना, वहाँ पे फिर से वो सेटलमेंट।
है। हाँ, सी ऐसा नहीं है कि इसमें इसमें स्ट्रेंथ नहीं आता है। नहीं, मजबूत तो ये भी कर देगा, मजबूत नहीं करना इसका मोटिव नहीं है, बट स्ट्रेंथ के लिए हम इसे यूज नहीं करते। मैं ये कहना चाह रहा हूँ, ग्राउट सीमेंट हो गया या फिर एक्सपेंसिव सीमेंट, कोई भी एक्सपेंसिव एजेंट, उसको हम स्ट्रेंथ प्रोवाइड करने के लिए यूज नहीं करते हैं, उसको इसलिए यूज करते हैं ताकि वो फिल कर दे उन एरियाज को जहां पे हम एक्सेस नहीं कर पा रहे हैं। जैसे कि कंजेस्टेड रीइंफोर्समेंट है कहीं पर एंड दोस कॉर्नर्स आर नॉट गेटिंग फिल्ड बाय योर कंक्रीट, तो उस केस में क्या करते हैं, हम उसको इन एक्सपेंसिव एजेंट से भर देते हैं ताकि आपका सरफेस फिनिश्ड हो और इसमें क्रैक्स ना हो और उसकी वजह से एडिशनल प्रॉब्लम्स ना क्रिएट हो। ठीक है। तो स्ट्रेंथ तो दो सारी सीमेंट्स देंगी थोड़ी बहुत स्ट्रेंथ, बट इनका स्ट्रेंथ देना इनका मेजर पर्पस नहीं है। इनका मेजर पर्पस एक्सपेंसिव फोर्सेस एक्सपैंड करके क्रैक और वॉइड फिल करना है। ऑलराइट।
जी सर, थैंक यू सर।
ओके, ऑलराइट। Moving on to the fourth question. A cement paste prepared with 400 grams of cement has a water to cement ratio of 0.42. What is the capillary porosity at the end of 1 year, assuming that maximum hydration has taken place? The catchy phrase here is maximum hydration has already taken place. So the cement paste is prepared with 400 grams of cement and has a water to cement ratio of 0.42. What is the capillary porosity at the end of 1 year, assuming that maximum hydration is
यस
taken
सर,
place?
जीरो आया था लेकिन
Yes,
भूल गए
can
कैसे
somebody answer
सोल्व
this
किए थे।
question?
लेक्चर में दिया हुआ था। जीरो, हाँ जीरो जीरो आया था। तो उसमें नहीं नहीं सर, उसमें लगता है थ्योरी वाला डायरेक्ट किए थे।
जीरो आया था, अच्छा। Okay, ठीक है. हाँ, the correct answer is actually 0. And if you have taken these few graphs from the lecture slides itself, and we can see here that when we add cement, let's say C grams of cement and W gram of water, the cement and water will react, and at a given time of hydration, let's say the degree of hydration will be H, meaning that some of the cement will have reacted with the water, while some of the cements will still be remaining unhydrated inside the cementitious matrix. So the degree of hydration is somewhere less than 1. So let the degree of hydration be H at a given time of hydration, and therefore in the final system we'll be having some amount of unhydrated cemented, which can be calculated as C into 1 minus H. But here in the question it has been mentioned that maximum hydration has already taken place. That means that the H is 1. Now if the H is 1, there is no unhydrated cement left, because C into 1 minus 1 will give you 0. So all the cement has already hydrated. So you'll have essentially in the final system what you will have is solid hydration products, gel pores, and capillary water and empty capillary pores, right? In any other given system where the degree of hydration is, let's say, H, you'll have some amount of, in the final system you'll have some amount of unhydrated cement, that is C into 1 minus H grams. Then you'll have of CH, let's say CH gram of solid hydration product. Then the volume occupied by the CH gram of solid hydration product will give you 0.49 CH centimeter cube. Gel pores will be around 0.19 CH centimeter cube. We have already calculated this in the lecture itself. Then we'll have capillary pores, and then empty capillary of 0.06 CH centimeter cube. And if we conserve the volume before hydration and after hydration, then we can find the volume of capillary water. The volume of capillary water can be found by this expression: total initial volume minus the volume of unhydrated cement minus the solid product of hydration minus the gel pores minus the empty capillaries, and that will give you W minus 0.42 CH. Now, the volume of capillaries, the total volume of capillaries will be the volume of empty capillaries plus the volume of capillary water. And we know that the volume of empty capillaries is 0.06 CH. So the volume of, and the empty capillary, so the volume of capillary water is W minus 0.42 CH. So the final expression for the volume of capillaries is W minus 0.36 H, and porosity is defined as volume of pores divided by the total volume, and therefore the final expression for capillary porosity will be volume of capillary pores divided by total volume, and this is the expression. PC equals W by C minus I'll write it over here. PC equals W by C, meaning the water to cement ratio, minus 0.36 H divided by 0.317 plus W by C. 0.317 plus W by C. Now we know that the maximum hydration has already taken place, so H tends to 1, right? So that will give us, for a water to cement ratio of 0.42, PC equals 0.42 minus 0.36 divided by 0.317 plus 0.42. And can somebody calculate this and tell me the answer? PC equals 0.42 minus 0.36 divided by 0.317 plus 0.42, and the answer comes out to be 0.08. Alright, and this is almost equal to 0 because this is the nearest value in the given options to this answer is 0. So the correct answer to this question is 0. The capillary porosity of this given cementitious system is 0. Right? Alright. Moving on to the fifth question, a cement paste was prepared with 300 grams of cement and a water to cement ratio of 0.3. Calculate the volume of gel pores in centimeter cube at the end of 1 year, again assuming maximum hydration has taken place in 1 year. So again, the phrase to focus over here is maximum hydration has already taken place. And has somebody attempted this question? Do you have the answer to this question? The water to cement ratio is 0.3, 300 grams of cement. So if you calculate the amount of water, that will be 0.3 times 300, and that will give you 90 grams of water. This is pretty straightforward. We have already discussed this, a part of this in the previous question as well. So already it is mentioned that maximum hydration has taken place. So H equals 1, we know that. And then we have to calculate the volume of gel pores. Now we know that the for the calculation of the volume of gel pores, we need to calculate the volume of solid products, because as you can see in the view graph on the right, we know that gel porosity is about 28% of the total volume of the solid hydration products. So let's say in order to calculate the volume of solid products, 1 gram of cement produces 0.23 grams of reacts with 0.23 grams of water. We have already seen that. So 300 grams of cement will react with 0.23 times 300. So 0.23 times 300 will give us 69 grams of water. So 300 grams of cement will react with 69 grams of water, and in turn give us 3 as the mass is conserved. So the weight of the solid hydration product will be 369 grams, right? Now we know that the specific gravity of solid hydration products, this has been discussed in the class notes as well. The SG of solid hydration products is 2.51. And now we can use this to find the volume of the solid hydration product, and that will be 369 divided by 2.51, and that comes out to be 147 centimeter cube. Alright. Now that we have the total volume of the solid hydration product, we also know that it has been mentioned here, as you can see in the view graph on the right, 28% of the total volume occupied by the hydration products is the gel porosity. So that means the total 72% of the total volume occupied by the hydration products is actually the volume of the solids. So that means 72% of X is equals to 147 centimeter cube. Then X equals 204 centimeter cube, right? So the total volume occupied by the solid hydration products is 204 centimeter cube. That means 28% of this volume, 204 centimeter cube, is our gel porosity, and that comes out to be 57 centimeter cube. So the correct answer to this question is the gel porosity or the volume of gel pores is actually, sorry, not the gel, yes, the volume of gel pores is 57 centimeter cube. Gel porosity will be divided by the total volume, so that will be a factor, but volume of gel pores in centimeter cube will be 57 centimeter
Sir,
cube, right?
sir, ans- सर आंसर में तो 45,50 दिया हुआ है।
हाँ हाँ, राइट राइट, आंसर में 45,50 दिया हुआ है, but
इसका कोई
this is
डायरेक्ट
the answer that we
नहीं
are
है
getting
सर।
as per the I mean the lecture slides that it has been.
ये पूरा
वो approximate value दिया गया होगा, but direct formula
0.19
यही है।
ये तो 5.7 आ रहा है, 5.7 आ रहा है सर।
डायरेक्ट फॉर्मूला भी यही है 0.19 सी।
हाँ तो 57 आ जाएगा सर। हाँ जी सर।
300 ग्राम में 300 इंटू 0.19 और h इक्वल्स 1 है,
हाँ
तो वही 57 आएगा। तो ये तो मैंने आपको एक्सप्लेन करने के लिए बताया है कि कैसे जेल पोरोसिटी कैलकुलेट होता है, बट डायरेक्ट फॉर्मूला यही है 0.19 CH, और उससे भी आपको सेम ही आंसर आएगा।
जी सर।
ठीक है, alright, moving on to the sixth question. Choose the correct match the following properties of cement with the apparatus used for the testing. So on the left side column, the different properties of cement has been given, and on the right column, the different apparatus used in order to calculate these values of these properties have been mentioned. The left side is properties and the right side is test apparatus, right? The first one is standard consistency, second property is soundness test, and the third property is specific gravity.
सर वो स्टैंडर्ड कंसिस्टेंसी बिकट्स apparatus और फिर हो जाएगा साउंड टेस्ट जो करते हैं वो ले चैटियर बिकट्स apparatus
Standard
में
consistency,
साउंडनेस टेस्ट हो गया
because
सर
apparatus,
ले
right?
चैटलियर apparatus और स्पेसिफिक ग्रेविटी
So
हो गया
1, 2, 3.
apparatus। ले
Soundness
एगो जो बच गया
test
है
is
सर ले
Las
चैटलियर
Ateliers
प्लस
apparatus, or specific gravity is Las Ateliers flask. Right. So this is a very straightforward question. These are the correct answer, right? The seventh question of this assignment was, what is the angularity factor of a sphere? 1.9, 1.24,
1 सर
1, none of the above. Which of these options are correct?
एंगुलर
1. Right.
फैक्टर
How is the
तो
angularity factor of a sphere 1?
ये तो लगता है
Okay.
असाइनमेंट से इसी फोटो अथी में था सर डायरेक्ट लगता है।
All right. The angularity number of a sphere um, is 1 because angularity number of aggregates can be defined as the 67% minus the solid volume of the given aggregate type occupied in a standard vessel which is filled in a standard manner as a ratio of the amount of water that is filling the voids in that vessel when the aggregate is already there and the specific gravity of its aggregate. So basically, if I explain it to you in a very simple way, um, when rounded aggregates are packed in a certain I mean in a certain volume, when rounded aggregates are or spherical aggregates are packed inside it, the solid volume that is occupied by these spherical aggregates is 67% and 33% of it is voids. All right, and we know that spherical particles have the best packing. Now, if we deviate from a spherical shape to an angular shape or any irregular shape, then the packing density also reduces. So the volume fraction occupied by the solids or the aggregates will be lesser than that of 67%. So in order to calculate the angularity number, we subtract the solid volume occupied by the aggregate type from 67% and calculate the volume of these aggregates by dividing the specific gravity with its weight and uh, explain it or express it as a ratio with the volume of the water that which is occupying the voids inside it. So angularity number can be expressed as the solid volume in or the solid volume lesser than 67%, or in other terms it can also be explained as the void volume in excess of 33%, because 33% is the void volume that is occupied by spherical aggregates. So this is how the angularity factor is expressed, and the angularity factor of a sphere therefore is 1, right? So that's the end of the today's assignment questions. If you have any doubts, then we can take your doubts. Otherwise, the session will go on till 8 p.m. So you're free to leave if you don't have any doubts. If you have any doubts, then you can stay and you can put up your doubts now and we can discuss them. All right.